So for each Riemann sum, we are estimating the area underneath the curve using the area of rectangles. And depending on what kind of Riemann sum it is, it's telling us what height we're going to use for the y values, because it is just an estimate. For all of these, we're going to use 3 subintervals. So the first thing to look at is the fact that if we're going from 0 to 6, and then I'm using 3 subintervals, I want to divide my whole range by 3 to see that each of those is going to be 2 units long. For a right Riemann sum, that means that my rectangle is always going to use the height of the value on the right. So on our first subinterval from 0 to 2, I want to use the y value that goes with my x that's on the right. So my f of 2 here is 3. So the area of that first rectangle is going to be a 2 by 3. In between 2 and 4, again, I'm using the y value on the right. So I would have a 2 by 2. And then for our last rectangle, my f of 6 is 6, so I have a 2 by 6. We can also use that shorthand because the width is going to be the same for all of these rectangles. I could have my 2 on the outside and then do 3 plus 2 plus 6. That might be helpful if your problem is lengthy, but if it's short like this, you might as well just write out the area for each rectangle. For a left Riemann sum, the only difference is that for each interval, I'm going to use the y value for my x that's on the left. So for 0 to 2, I will use f of 0. So this first rectangle is going to be much smaller. I'll have a 2 by 1. For the next subinterval from 2 to 4, I'll be using f of 2, so a 2 by 3. And then in between 4 and 6, I will use f of 4 for the height. So I'll have a 2 by 2. For a midpoint Riemann sum, now the height of the rectangle is going to come from the x value that's halfway in between each interval. So for my interval from 0 to 2, since 1 is in the middle, the midpoint, I will use the f of 1 as the height. So I'll have a 2 by 2. From 2 to 4, 3 is the midpoint, and its height is 1. And then 5 is the midpoint of the last interval, and its height is 4. Our last two are the upper and lower sum, and that just means that for each interval, I'm going to choose the y value that is the highest between the two endpoints. So whether my f of 0 or my f of 2 is higher, in this case f of 2 is higher, so I'll use f of 2. And between f of 2 and f of 4, f of 2 is higher again, so I use that y value twice. And then between 4 and 6, f of 6 was higher, so I used f of 6. For the lower sum, I end up using f of 0 for the first interval, f of 4 is the lowest for the second interval, and then f of 4 is also lowest for the third interval. Also notice on these that the midpoint is not an option. You're choosing between the left and the right. And then last but not least, we have lumped in with the Riemann sums the trapezoidal rule, which is similar in the fact that we're estimating an area, but instead of using rectangles, we use trapezoids. So for the interval from 0 to 2, I'm going to use both my height at f of 0 and my height of f of 2 to create a little trapezoid, where my parallel parts of the trapezoid, so f of 2 and f of 0, are the bases of the trapezoid. So if we're finding just the area of this one trapezoid, we'd have 1/2, 1 plus 3 times, they're all going to have a height of 2. So they're kind of on their sides, if you imagine, if you want to see your trapezoid that way. It's kind of sideways. For our second subinterval, that trapezoid has bases of 3 and 2, and again a height of 2. And then our last trapezoid has bases of 2 and 6, and then a height of 2. Okay, so this is one where shorthand is pretty nice to use, because especially if I have a bunch of trapezoids, because they all have this 1/2 and then they all have the same height. So I could say 1/2 times 2, which is actually just 1. And then I just noticed that the 3 is used twice, the 2 is used twice. Anything here in the middle, it's going to be that same base twice. So we've got a 1, and 2 3s, and 2 2s, and a 6. So that can be a little helpful to rewrite it that way. So sometimes when we're asked to use a Riemann sum, we're given a table. And then also when we're given that table, we may not have even subintervals, and that's okay. We'll just use whatever they've given us in the table. So this is telling us that a tank contains 50 liters of oil at time equals 4 hours. So we will have to take that into account. And then it's being pumped into the tank at this rate where it's telling us selected hours, what that rate is being pumped in at different hours. We're using a right Riemann sum with 3 subintervals, so we're just going to have 1, 2, 3. So just using the numbers they gave us to approximate the number of liters of oil that are in the tank at time equals t equals 15 hours. So first, when we're finding the total here, we want to make sure that we are finding 50 because that was the original, plus the amount that gets pumped in from 4 to 15. We weren't given RT. So make sure at the end here that we're adding 50 to it. But now when we go to estimate this interval, we're just using that right Riemann sum. So in between 4 and 7, the width of that rectangle is 3. So just the difference between 4 and 7. And then we want to use the value on the right. So the y value on the right is 6.2. In between 7 and 12, there's a width of 5. And then the value on the right is 5.9. And then our last one, in between 12 and 15, is a width of 3. And then the value on the right is 5.6. So you should get 114.9 liters. I do want to also mention that if you're working one of these on a free response question, I think it's worth it to take an extra 30 seconds to write it as 3 times f of 7 so that you're showing that AP grader, I know that I'm choosing the value on the right, f of 12, f of 15. It's a little step to add in there, but I think it would be helpful for the person grading it to know that you know what you're doing. Okay, so this next one is a trapezoidal sum, and we're just focusing on part B here. But I do want you to go ahead and see if you can set this up on your own. Make sure you are reading the whole question. So a few details that we need to pick out of this question. First, the fact that we're talking about the first 4 hours. So I don't even care what's happening for this 7 to 9. I want to focus just on this part. With 3 subintervals, that just means I'm looking at 0 to 1, 1 to 3, and 3 to 4. Notice that that 1 to 3 is not the same width as 0 to 1 and 3 to 4. And then when we're done finding the total number of people, we are going to have to find the average number of people, so that is really important as well. So for our trapezoidal sum, both the first trapezoid and the last trapezoid have a height of 1, so I didn't write that in. But then our middle trapezoid has a height of 2, so make sure that you've got that difference in there. The total should be 621, and that's the number of people that line up from 0 to 4 hours. But because we're looking for the average number of people waiting in line over that interval, we want to go ahead and divide by 4, which is just the length of the interval that we're looking at. Just like when we would find the average value of a function, and we would divide by the length of that interval of the integral of that function. Okay, for our last question, we're focusing on part C, and I do want you to go ahead and set up a left Riemann sum, but you don't have to solve it. I really want to focus in on this last question, does the approximation overestimate or underestimate the average temperature? So go ahead and pause the video and set it up, and then think through, what do you think there? So setting up this average using a left Riemann sum, first make sure your 1 over 20 doesn't disappear, leave it there. And then for the first rectangle, we've got a width of 4, and then we're using f of 0 since it's on the left. For our second subinterval, a width of 5, and then using f of 4 since it's on the left. For the third one, a width of 6, and then using f of 9 because it's on the left. And then for the last one, a width of 5, and then using f of 15 because it is on the left. So then to answer the question, and it might help you to graph it, but if we think about what's happening here, with every subinterval, when I choose the value on the left, it's the lesser of the two. So in between these two, f of 0 was the least, f of 4 was the least in the second subinterval, f of 9 is the least here, and then f of 15 is the least here. So we could explain it that way, but the reason that the value on the left is always the least is because this is increasing. So we can say because it's increasing, a left Riemann sum would have to be an underestimate. And remember, usually if they tell you something like that, so for this one they actually tell you that it's strictly increasing, we're probably going to use that somewhere in the problem.